Hello guys, welcome back to Maison African Motives, still on Mathematics N5. In this platform, we are going to be focusing on the derivatives. So working on differential calculus on question 2 of November 2022 question paper. So we are going to quickly rush through the questions that we are given so that we can quickly see what we're supposed to do. On 2.1, we are given derive a formula to determine dy dx if y is equivalent to or y is equal to arctan x. All right, that's 3 marks for that. Okay, so we want to find a formula that represents the derivative for arctan x. All right, so I'm just going to represent this aside here. All right, let's see what we're gonna have. All right, so this is question 2.1, and we can even write this as y is equivalent to arctan. All right, so that was arctan x like this, which can be written as y is equal to arctan of x like this. All right, so it's still one and the same way or same presentation that you're given there. All right, so if you are to check, this is y with respect to x. So for you to find the derivative of y with respect to x, arctan should not be taken direct. This is what we have. It's not supposed to be taken direct because we want to derive a formula. It's not like you know this direct. If you know this formula, if you know the answer, it's an advantage for you, but you are supposed to derive. Okay. So it's not going to work direct if you are having an arctan. So what you do is that you introduce arctan again so that we can have the value for tan of y. So if I introduce tan here, I'm going to have x. Okay, so we are going to introduce a tan on this side. We introduce a tan on this side. So a tan and its arctan, it's going to give us a positive x. All right, so you're just going to remain with x in that way. So we are going to have this as tan of y is equivalent to x. All right, so take note, we need a derivative of y with respect to x. So if we are to differentiate here with respect to x, we are going to see that it's not possible for us to find direct because this is in terms of what? In terms of y. So we are now going to apply the implicit concept where you differentiate with respect to y, which is going to be sec squared. Remember, tan gives us sec squared y. And you multiply by dy dx. Take note, because it was with respect to x, and here we put a term with respect to y. So we are going to apply the implicit, so that's dy dx, which is equal to, you do the same on this other side, you find a derivative with respect to x from this part, okay? So this is with respect to x, so we are going to obtain a 1. So here we are going to have 1. All right. So as we can see here, guys, we have the dy dx. So you can simply make dy dx the subject by dividing with sec squared y on both sides, sec squared y like this. So this is going to give us dy dx. So we can have, let me just write it aside here. So we can have our dy dx as 1 over sec squared. So this is 1 over sec squared y like that. But this is not exactly what we need because it's a derivative of y with respect to x. We are supposed to obtain an answer in terms of x on this part. We are supposed to have this answer in terms of x. So what are we going to do for us to have this answer in terms of x? We are supposed to refer back here where we have got a tan. Remember, previously we are given that tan y is equal to x. Okay, let me just write it down here. Previously, before introducing the derivative, we were given tan y here, which was equal to x. At least we can play around with this to find the equivalent of sec in terms of what? In terms of x. So if tan y is equal to x like this, what can we do to obtain sec squared? All right, we know that if we are to write that tan is equal to, if you are to square both sides, okay, let's say you manage to square both sides, we can have a tan squared here, tan squared of y, which is equal to x squared. So I want you to see that we can obtain tan, we can obtain this sec squared from tan. Since we know that from our identities on our formula sheet, we are given this identity, which is called sec, okay? It's given as 1 plus, okay, 1 plus tan squared x is equivalent to sec squared x. So check on your formula sheet, okay, on trigonometry. So if you are to check here, we can make this sec to be the subject, okay? Already it's the subject here and we need the sec. So we are given that sec squared is equivalent to 1 plus tan squared, and this is the one that we need here. This is sec squared y. So if we are to write this as in terms of y, we are going to just put y here, because this is supposed to be in terms of what? In terms of y. So 1 plus tan squared y is equal to sec squared y, like that, okay? Whereby already sec squared is the subject here from this formula in terms of what? Tan. So we are given that sec squared is equivalent to 1 plus tan squared, which is 1 plus tan squared y here. We said it is equivalent to what? To x squared. So that means we can write this as 1 plus x squared is equivalent to sec squared y in terms of x. So we just substituted tan squared with its equivalent, which is x squared. All right. So this is what we are going to have here. In place of sec squared y, we are going to write as 1 plus, all right, x squared. So this is dy dx is equivalent to 1 over 1 plus x squared. So the x squared is taken from where? From 1 plus tan y squared. So that is the equivalent in terms of what? In terms of x. So these were the stages that we just needed to derive the formula, because you are given this formula in your formula sheet. Now they want you to derive where exactly it was taken from. All right. So that was question 2.1. And on question 2.2, we are given to find or to calculate dy dx of the following by using the derivatives, okay, and of sine and cos. So take note, guys, this part when I was trying to convert this, it changed everything. So this is sine of x and cos of x, okay, as well as the rules of differentiation. We do not know which rule exactly are we going to use. Okay, so we are given that y is equivalent to, this was like pi to the exponent of log, okay, cot of x, cot x like this in base of what? In base of pi. So this is what you're given. And we are given a hint here that a, when raised, okay, let me write it this way. When a is raised to log of x in base of a, the answer is going to be x. It's a hint that we are given in this case. Okay, so what can we do, guys, in order for us to find this derivative of the question that you're given? All right, I want us to check at the hint that we're given. You're supposed to know these, guys, from your logarithms, okay? If you are to raise a certain number, it's a to the exponent, and the base here is the same. We've got a, and we've got a on the base. The answer is going to be x. This is the same condition that we have here. We've got pi on the base. We've got pi on the base of a log. So this whole value is going to be equivalent to x, but our x in this case is written as what? As cot x. So this is equivalent to cot x. So the question was simply for you guys, differentiate y is equal to cot x. But see how they were trying to hide this part. Okay, so how can we differentiate? How can we find the derivative of what? Of cot x, okay? So remember, we are told to use sine and what? And cos. So, okay, let's write this aside so that it can help us, okay? So I'm just going to clear this part here. All right, so we have got y, which is equal to cot x now. So this is question 2. 0.2. So we simplified everything, then we got y is equal to cot x. So remember that from your trigonometry, the cos or the cot of x is equivalent to cos over sine. So this is the cos of x over the sine of x, which is taken from what? From 1 over tan x. Remember, tan is sine over cos. So 1 over, that is going to give us sine over cos over sine. So we can rewrite this as y is equivalent to the cos of x over the sine of x. So how can we apply the derivatives in this case? We can see that this is actually the quotient rule that we can apply. So remember, from your quotient rule, guys, you can write this as your ux and this as your vx. All right. So from our derivative, the formula is going to be the derivative of y with respect to x is equivalent to vx. So you can write our formula as vx by the first derivative of ux. Okay, then we subtract. This time we are going to start with ux. So it's ux by the first derivative of vx over vx squared. All right, so this is the formula that you're going to use, or someone can use this as v du dx if you write the du dx minus u dv dx, depending with the way that it's comfortable with you guys. All right, so the derivative of y with respect to x is going to be equal to vx, of which our v in this case is equivalent to sine of x. So that is going to be sine of x multiplied to the first derivative of u. Our u is cos. So take note, u is cos. So the first derivative of cos, remember, cos, guys, gives us a negative sign, okay, minus ux. Our u is cos of x, so this is going to be cos of x multiplied to vx. This is the first derivative of v, so the first derivative, if you differentiate sign, you are going to obtain the cos of x. All right, everything over vx squared, that is our vx in this case, which is sine of x. So this is going to be sine of x squared. All right, so we can actually simplify this further. If we to multiply the sine and the sine here, we are going to obtain negative sine squared x. All right, then we've got negative cos and cos, which is going to be negative cos squared x. All right, everything over sine x squared is same as sine squared x. Remember, this is sine times what? Sine times sine. All right, so we can simplify as much as we can because on the top there, we can see that a negative is common. So we can factor out a negative from negative sine and negative cos, which is going to be negative sine squared plus the cos squared of x, everything over sine squared x. Okay, take note, we have got an identity here, sine squared plus cos squared, which is equivalent 1, okay, from our trigonometry. Sine squared of x plus cos of squared is equal to 1. So that means at the end, the whole answer is going to be negative 1 over sine squared, like that. So it's going to be negative 1 over sine squared x. But what is the equivalent for 1 over sine? We know that 1 over sine is equivalent to cosec, but this is 1 over sine squared. So it is going to be negative cosec squared. Also, there's a squared. So you also have to square your answer. So your answer is going to be negative cosec squared. So this is what the person was asking you to apply, to use cos and sine on your derivative. Then the rules. So the rules that we used, the rule that we used here, that is the quotient rule. Remember, you're dividing, so we have to apply the quotient rule in this case. All right, so that was question 2.2. We are going to move on to question 2.3, where we are asked to determine dy dx. So take note, we are given that simplification in this case is not required. Okay, simplification not required. So 2.31, we are given that y is equivalent, that is tan like this, tan in bracket x squared, then we are, that is x cubed, that was x cubed, sorry, and this was ln squared x. All right, so just guys, this was a shift there when I was trying to make this paper. Okay, so that was what we're given in this case. So how can we find the derivative of this type here in this case? Okay, so remember that the simplification is not required. So these questions, we can actually do the derivative by side. By just looking at the question, we can do the derivative. Okay, so let me rewrite this question aside where we put space here so that it can help us. So this was question 2.31, where we are given that y is equivalent to tan x to the exponent of 3. Then we have got ln squared x like this. Okay, if you are to check here, we have got a function of a function that we have. We can use the x cubed ln. That to note here, we have got a function of a function that we are supposed to apply in this case. All right. So take note, x cubed ln squared x is a function that we have, which can be taken as x cubed. Remember, ln squared is same as we are writing as ln x to the exponent of 2 like that. Okay. This is not ln x squared. So take note, we are not supposed to write like this. Okay. So like I said, we've got function of function. So remember, what we are supposed to do is we find the derivative of the function, which is this one inside of x, okay? This is our function, which is our f of x. Then we find the derivative considering the trig, which is this trigonometry part of tan, of which you know that tan is going to give us sec squared, okay? So on finding the derivative of this function, we have got a product, okay? Here, these two functions, they're multiplying each other. So this is a product where we can have this as ux and this as vx. So which means the first derivative was supposed to be like this, guys. The y dx was going to be, remember, from your product, we are supposed to have our formula, or from our formula sheet, guys, we can have this as ux, okay, that is ux by the first derivative of v plus, we can have this now as vx, or just the first derivative of ux now by what? By vx. All right. So any way that you can, this formula can be given in many ways. I don't know which one, which exactly the presentation that you want. Okay. So that means in this case, we have got ux, which is x to the exponent of 3. All right. Then we move on to the derivative of v, of which our v in this case is ln x squared. So how are you going to find the derivative of ln x squared like this? All right. So for ln x squared, it's now back to function of a function again, where we are going to let this to be a function. So we're going to find the derivative of ln as it is here, which is going to be 2 ln of x by working with what? With the exponent. All right. Then we find the derivative of the function now that we are referring as a function, which is what? Ln x. And we know that it's 1 over x. So this can be in different way. You can even write it in terms of what? In terms of this, to write it as 1 over x, then 2 ln x. So it depends with the way that you want to write this one. Okay, so this is what you're going to obtain from this derivative. So here, remember, these two are multiplying. So we obtained 2 ln of x by 1 over x. So this is 1 over x. Remember, the simplification is not required. All right. So this was the derivative of v. Plus, we move on here. We are now having vx, the first derivative of u. So this is the first derivative of u, which is we are referring to x to the exponent 3, which is going to give us 3x squared by vx. So the vx is going to remain as it is, of which our vx was this part of ln x squared, which was written as ln squared x. So you can write this as ln squared x, or you can write it as ln x squared. All right. So that was the derivative of the function, which I referred to as f of x, this whole part here. So this is the derivative. Okay. Whatever that we are going to obtain from that function, we now find the derivative of tan. All right. So this is just by looking at the question, you can find, okay, so the derivative of tan, we know it's sec squared. So it is going to be sec squared. Then inside this remains as it is, which is x cubed ln squared x, like that. Okay, so that is everything is being differentiated by doing this. Okay, so that was question 2.31. Let's check the other part of the question. All right, let's check the other part. All right, here we are now given on 2.32. All right, so let's just remove this part so that we can properly work out our question, guys. Okay, so this is question 2.32. All right, with 4 marks, everything 4 marks. So the question was actually lean. Let me write aside because here it's not given properly. Okay, sorry for that, guys. So this is question 2.32. All right, so we were given this as y is equivalent to the square root of, that was ln, okay, 2x, we've got ln 2x plus 3, everything over 4, and we've got the square root of 3x minus 1, like that. Okay, so what can we actually do in this case? We can see this is the quotient rule. We can apply our quotient rule because we've got a function in terms of x, which is our ux, and this is our vx. Okay, so if you are to relate this, guys, I want us to see something here. If we are to relate to our function so that we can find its derivative properly, this square root of ln can be written in this manner. This can be written as the ln of 2x plus 3, like this. So the square root means to the exponent of a half. I just want you to understand what it means. So this is same as to the exponent of a half, okay? Everything over, this is 4 square root of. So it can be written as 4 into 3x minus 1, like this, to the exponent of a half, to represent what? The square root. All right. So that means in this case, if we are to find the first derivative from our formula, we know that the formula is supposed to be dy dx is equivalent to, that will be v. So this time you definitely have to start with v. So that's vx by the first derivative of u minus, you can start with u or you can just start with the first derivative depending with what you want in this case, okay? But this is going to be ux by the first derivative of v, all right, over vx squared. So the presentation on these two does not matter. You can start with the first derivative, you follow vx. You can start with the vx, then the first derivative. So what I'm simply on these two, you can, this order on these two does not matter. Also, this order on these two does not matter. But do not interchange now across like this. Once you do that, now it's wrong, okay? All right, so that is what I'm trying to say there, all right? So what you're going to have in this case, let's see, okay, let's do it stage by stage. So we've got the derivative of y with respect to x, which we can take our vx as it is because this is direct, guys. So our vx is either we can write it in this format of 4 into this to the exponent of half, or you can write as it was before, which is 4 the square root of 3x minus 1, or you can write it in this manner, okay? Then the first derivative of u, so whatever that you're going to have here is supposed to be from the first derivative of u, of which this is our u in this case. This is the first derivative. Remember what we did previously to find the derivative, okay? This is function of a function where you need to find the derivative of the function inside here, all right? Or we can just use ln, okay? Let's use the ln, guys, as the whole function. So we're supposed to find this whole of ln as a function. So this is going to be your function, the whole of ln like this, okay? Of which you know that the derivative of ln, because we're supposed to find the derivative of this function, which is ln, which is going to be 1 over, so we are going to find the derivative of 2x plus 1, which is 1 over 2. So we are going to have this, guys, this way. All right, so this is going to be 1 over 2. Then if we are to check in this case from the ln, it was supposed to be f of x over, all right, we have the derivative of 2x, which is inside here, the whole of 2x, which is going to be 2. So this is 2 over 2x, okay? Then we move on to the whole function consisting of the ln, where we've got 1 over 2. All right, so take guys, okay, I'm repeating the same thing here. All right, let me do this. I've repeated the same thing. I was just supposed to take it this way. Let me start with the ln. Okay, so the ln, if you have to start with the half here, it is going to be 1 over 2. Then we have got the ln of 2x plus 3 like this. Okay, so remember that if you are to find the derivative of this, considering the exponent, which is or half here, we subtract a 1. So the moment we subtract a 1, that means it's going to be half minus 1, which is negative 1 or negative 1 over 2. All right, then that we are done with the whole of this function considered as ln of the whole function, okay? Then if we are to check inside, we have got the function represented with 2x plus what? Plus 3. So what are we going to do on 2x plus 3? We find the derivative, okay? If we are to find the derivative of 2x plus 3, this is going to be a 2. All right, so we have managed to find the derivative of this function, which is the ln 2x plus what? Plus 3. But take note, guys, it's like, let me write it this way. Ln 2x plus 3 like this one, okay? Then everything is being raised to the exponent of 3. It's like you have taken this to be a function, all right? This to be a function that you're going to find its derivative, all right? Then after finding its derivative, okay, this is to the exponent of the half. Where am I getting the 3 now, guys? This is to the exponent of the half, sorry. So it's like you are finding the derivative of this function, which is the ln. Then you find the derivative of another function, which is inside here, which is 2x plus what? The 2x plus 3. So there are two functions that we have, all right? So here we find the derivative of this one inside, which is the 2x plus 3. What about the one that is out, which is the ln 2x plus 3? So this one, we know that for the derivative of ln is f of the first derivative of f of x, which is 2x, which is going to be the first derivative, which is going to be 2 over f of x. Okay, so let me just write it properly here. So we're going to have the first derivative of f of x over f of x like that. So the first derivative is the 2 over the f of x. So this is going to be the ln now, okay? So this is going to be divided to ln. I just hope this part you understand me. So this is going to be ln 2x plus what? Plus 3. All right. So that is what you're going to have in this case. Then if you are to check, we have got a minus. In this case, we've got a minus vx. All right. So, all right. So vx, that's ux, or I don't know where am I getting the v. This is ux. So our ux in this case is this part in the numerator as it is. So you can just rewrite as it is. That is the square root of ln. Okay, the square root of ln 2x plus 3, which you can write this as ln 2x plus 3 to the exponent of half. Is one and the same thing, okay? But you are going to find the first derivative of v, that is, you have to find the derivative of this function, which is 4 into 3, x minus 1 to the exponent of a half. So this is function of again, okay? So what are you going to do? Find the derivative of the whole function, which is having a half. So this half is going to multiply 4. So it's 4 times a half. So we're going to multiply 4 and a half in this case, okay? Then we subtract 1 and exponent. So it's going to be 3x minus 1. Half minus 1, that's a minus half, okay? Then we find the derivative now of the function, this 3x minus 1. So 3x minus 1, that's a 3, okay? So we're going to multiply by 3, okay? I just hope this one was clear. So this is what you're going to have, guys, okay? So this one can be combined together. This one can be combined together. Everything is over Vx squared. So everything here, all right? Everything is over Vx squared, of which our Vx is this part, 4 square root of this, or you can write this as 4 into 3x minus 1. I don't know which one was best for you. I'm going to try the 4 square root of 3x minus 1, everything to the exponent of 2. So this is our Vx. So take note, the simplification was not even required, so you can leave your answer like that. So guys, just have to revise as much as we can. This part I know you need as much revision as possible. Okay. On the other hand, we are given 2.4 to apply or to use the logarithmic differentiation. Okay, so how can we apply the logarithmic differentiation in this case? If we are given this, okay, let me rewrite this part so that you can clearly see, because this one was not clear. So this is 2.4. So we are given in this case that find or calculate dy dx if y is equivalent to, so this is 1 plus arc sine x. Okay, so that was 1 plus arc sine of x. Then we've got ln cos x, like that one. Okay. So remember that if we are to use the logarithms, guys, we are supposed to introduce ln. Okay, we introduce ln both sides of the equation. All right, so if we are to introduce ln here, we introduce ln here, we are going to see that here there is now an exponent. Remember, ln of m to the exponent of n is same as any ln m, like that. So you can drop this exponent, okay? So what I'm trying to say is that here we are going to have the ln of y, which is equal to, we drop this exponent, which is going to be ln cos of x, okay? So we've got ln cos of x by ln 1 plus the arc sine of what? Of x, like this, okay? So remember that we are supposed to find the derivative of y with respect to x, both sides, the derivative of y with respect to x, the derivative of y with respect to x, both sides. Okay, so here we do not have x. We are given an expression in terms of y. So we're going to find the derivative of y, which is ln y is 1 over y. So this is 1 over y. Then you multiply, this is ln, which is 1 over, then you multiply by dy dx from your implicit function. Okay, so this is going to be dy dx. All right. Then if you are to move on here, we are to see that this is we've got two functions that we have in this case. This is a function, okay? We've got a function here, which is our ux, then we've got our vx, and these two are multiplying each other. So that means we can apply the product rule in this case. All right. So how are we going to apply the product rule? So remember, we can write our formula. This formula, guys, like I said, it can be in any way of your choice. So you can write this as ux by the first derivative of vx plus the first derivative of ux by vx. All right. So ux, it's ln cos of x. So this part is not going to change. You are going to write as ln cos of x, like this, okay? By the first derivative of v. So this is our vx. So to find the first derivative, take note, guys, this is ln of a certain function. So we are now back to function of a function, or we can just say, okay, this is ln. How do we find the derivative of ln, okay? So remember that the derivative of a ln, we are supposed to find the first derivative of the function over f of x, like this. So this is your f of x. So you find the derivative. So the derivative of 1 plus arc sine, okay? So this is 1 plus arc sine. Okay, so what we actually know is that from this derivative, how many functions do we have? We've got one function and another function for what, for ln. So which means we've got two functions in this case. So here, the derivative of a 1 here, because we're going to refer to 1, okay? So this is the derivative of 1, which is a 0. So here we're going to obtain a 0. Then we move on to arcsine of x, okay? So from your derivatives, we know that arcsine is the square root of, it's 1 over, so this is 1 over the square root of 1 minus x squared, okay? So we're going to obtain something of this nature, but whatever that we have, we divide by the function of x. So the function of x is this 1 plus whatever that we have, so it's going to be 1 plus arcsine of what? Of x. So this is what you're supposed to have. So take note here, we are dividing this fraction and this one. So at the end, we are going to have something like 1 over everything. So it is going to be 1 over like this. It is going to be, let's just write it this way, 1 over the square root of 1 minus x squared by 1 plus arcsine of x. All right, so this is what you're going to have at the end. So take note, it's like we've got a over b divided by c. It's going to be a over bc if you divide, okay? This is a single fraction, okay? So that is what we have for the derivative, okay? Which was the derivative for v, okay? Then we move on plus the first derivative of u this time. So this is plus the derivative of u. If you are to check our u, it's lean cos, which is the same as what we did previously, where we said this is a function of x, which is cos. So from the formula, we are supposed to have the first derivative of f of x here, which is cos x. So the derivative for cos, that's negative sine over f of x. So our f of x in this case is cos x. So it's going to be negative sine x over cos of x, like that, okay? Of which you know that this is going to be a tan, okay? If you're given like this, it is going to be a tan. So take note, this is the derivative of cos changing to a negative sign in this case, all right? Then whatever that we are going to have, we multiply to Vx, of which our Vx is this whole function of ln, which is, let me write it this way, which is ln 1 plus arcsine of x. So this is arcsine of x like this. All right. So that is what we have. So like I said, this is the first derivative of u. This is Vx, okay? The same here, this is ux, this is the first derivative of v. All right, so we can simplify this further. We can simplify everything that we are given in this case. Okay, let's try to simplify as much as we can. We can see that here we can combine, okay, we can just choose to leave it like that with the negative, but knowing that this is a tan, okay? So by remaining with the dy dx here, it means we can multiply by y both sides. So if you have to multiply by y here, it means everything here has to be multiplied by what? By y, so that this can cancel. You remain with dy dx. So our dy dx in this manner is going to be equivalent to the ln of cos multiplied to this. So take note, we've got a y that we have now. Then the ln of cos is like over 1. So this can be written like over 1. So if multiply, you can multiply the numerator, that's times 1 here. You're going to obtain ln cos of x, everything over 1 times this part, which is going to remain as the square root of 1 minus x squared. Okay, we can just put this in a bracket, times 1 plus the arcsine of x. So this is arcsine of x, all right? So whatever that we have here is going to be a negative because it was negative sine over cos. So this can be negative tan x, all right? So it can be negative tan x into ln. So this is ln 1 plus arcsine of x like this, all right? So this can be written in this manner. But remember that everything that you're going to have here is to be affected, or you're going to replace the value of y, of which we are given before, that y is equivalent to 1 plus. So this is the expression for y here before we introduced the ln here. Y is equivalent to this part. So you're going to substitute now in place of what? In place of y, okay? So that means we are going to have this, everything that we have got there, that is your y, you substitute as it is. So therefore, our dy dx in this case is going to be y, which is equivalent. It was 1 plus the arcsine of x, and everything was raised to ln cos of x, all right? Then this part, you repeat it as it is here, all right? So you're going to repeat this part as it is. That is the ln of cos of x, everything over the square root of 1 minus x squared, okay, into 1 plus arcsine of x, all right? The negative tan, so this is negative tan x into ln 1 plus arcsine of x. All right, so this is what you're going to have at the end as the derivative of y with the respect to x. So it must be very, very careful, guys, when your derivatives, there are so many things that we need to work on, to learn, and to revise on as long we are dealing with derivatives. Okay, so these are the typical questions that you can actually have, all right? And on the other part of the question, let's check what we're given. That's question 2.5 now with 5 marks. Determine dy dx of the implicit function. Remember, an implicit function is the one that we cannot make y the subject, or we cannot make x to be the subject either. Either way, we can't make x the subject, we can't make y the subject. Okay, so I'm going to write down the equation, because here these numbers, they just shifted. So I'm going to rewrite the equation, okay? But that is what we had on 2.5, which is actually 5 marks to take 23 marks on question 2. There's a lot of marks on question 2. All right, so we are given 2.5. The question was given as 2x minus 3y like this over x plus y is equivalent to, or is equal to, 2x plus y squared. All right, so if you are to take a closer look here, from our implicit function, it's difficult for us to find the derivative like this. So what we can simply do is to cross multiply, because this is same like over 1. So we can just cross multiply so that we can see what's going to happen by expanding the brackets. So that's 1 times 2x minus y, which is 2x minus 3y is equal to. So here we've got 2 brackets. We are going to have 2x plus y squared, which is multiplied to x plus y like that. Okay, so expanding our brackets, we are going to have 2x and x here. So remember, guys, 2x is to multiply everything, 2x and x, then 2x and y, which is going to be 2x squared. So we are going to have 2x squared, then 2x and y, which is going to be 2xy, okay? We are done with 2x, then we move on to y squared. So it's y squared times x, which is xy squared. Then it's y squared times y, which is y to the exponent of 3. Okay, that's y squared times y. We add the exponent. So remember that from your implicit function, what you need is to find the derivative of y with respect to x. So each and every part, we are going to find the derivative with respect to x for each function that you're going to have, either in terms of x or in terms of y. Okay, so let's start with 2x. So the derivative of y with respect to x, all right, this is going to be a 2. All right, or what we can do before that, we can choose to take our terms to one side of the equation. That's another way of doing this, okay? Or we can just find the derivative here. So here, this is going to give us a 2. So that's 2. All right, minus 3y, take note, this is with respect to y. So you find the derivative of y, which is negative 3. Then your answer is going to remain with dy dx, okay? Which is equal to, we have got 2x squared. You drop the exponent, so it's 2 times 2, which is going to be 4. So that's 4x. Remember, here there is x only, so it's going to be 4x, all right? 2xy, take note, this is a product. We've got 2 functions that we have, which is our u and our v in this case, okay? So remember that from our formula, we had this as ux, the first derivative of u, of v plus This time Vx, the first derivative of what? Of Ux. I don't know which way do you want it to be written? Okay, so that means this can be our Ux, which is 2x as it is. So this is going to be plus 2x. Then Vx, the derivative with respect to x, here we're given y on V. So the derivative of y is a 1. So it was supposed to be 1 dy dx like that. So what dy dx, guys, you can just write it as dy dx, or you can write it as the 1 dy dx, whatever way, still is fine, okay? Here we are multiplying, not adding, because this is 2x, this is Vx by, okay, this is Ux by the first derivative. So this is Ux, which is 2x by the first derivative. So the first derivative, we got dy dx, we are going to multiply, okay? So the question here, we are supposed to multiply, okay? Plus Vx, so we are going to add plus our function here for V, it's y, so this is y times the first derivative of u, which is the derivative of 2x with respect to x, it's a 2. So this is y times 2, okay? Plus, we move on. If you are to check, we have got the same thing again on this part, x and y squared. So this is going to be your u, and this is going to be your v. So from our formula, guys, we talked about this. So this is ux, which is our u, it's x by the first derivative of v, which is the first derivative of v, it is with respect to x, but here we are given as y. So it is going to be 2y, then you multiply by dy dx. So take note, these two are multiplying each other, okay? Plus vx, the function for v, this is y squared, so it is going to remain as y squared, but we have to multiply to the first derivative of u, which is our u in this case is x. So the first derivative of x is a 1. So multiplying by 1 does not affect, guys, okay? Plus, we still have another function, y to the exponent of 3. So with respect to x, this is going to be 3y squared. Remember, you drop the exponent, we subtract 1. So this is 3y squared, but with dy dx like this. Okay, so this is what we are going to have, guys, and we can simplify. As we are simplifying, let us all try to be collecting terms with the dy dx on one side of the equation. We have got dy dx here, we've got dy dx here, we have got dy dx here, we have got dy dx here. So you can simply transpose, because as you can see, more of these, they are on the left-hand side, they are on the right-hand side. So we can transpose the negative 3 dy dx to the right-hand side. So that means on the left-hand side, we are going to remain with 2. We transpose other terms without dy dx. That is, we are referring to this 4x, all right? We are referring to 4. So if we transpose to the left-hand side, it is going to be negative 4x. We move on here. This is y times 2, which is 2y. So if you transpose, it is going to be negative 2y, okay? Here it's y squared times 1, which is y squared. If you transpose to the left-hand side, it is going to be minus y squared, okay? So these are the terms that we have on the left-hand side. Then the rest with the dy dx, remember, we said we are going to transpose this negative 3. So before we forget about this, let's transpose it now. If we transpose this to the right-hand side, it is going to be a positive. Remember, it was a negative. So this is going to be 3 dy dx, all right? Here we've got 2x. We are going to have 2x dy dx, all right? On this one, it's x times 2y here, x times 2y, which is 2xy dy dx, okay? Plus, here, on the other end, we've got 3y squared dy dx, all right? So we know that dy dx is common throughout, so we can choose to factor out that dy dx so that we are going to remain with the numbers 3, 2x, 2xy, 3y squared. So if you factor out, you're going to have 3 plus 2x plus 2xy plus 3y squared. Everything now is affected by dy dx. So you can factor it out, okay? This is equivalent to everything on the left-hand side, which is 2 minus 4x minus 2y minus y squared. So to find dy dx, definitely we are going to divide by this bracket. So therefore, our dy dx, if you divide by the bracket here, we are going to have it as 2 minus 4x minus 2y minus y squared, everything over the bracket that we divided with, which is this bracket of 3 plus 2x plus 2xy plus 3y squared. Okay, so that was our dy dx. So the order here does not matter. Someone might start with negative y squared, negative, the order does not matter. What matters are these numbers with the signs that they have. Are they corresponding properly? If they are corresponding with the ones that you have there, then it means we are together. But if they are not corresponding, please recheck your question again so that we can move together. So that was the question. These were the questions actually that we had from this question paper of November 2022 differentiation on question number 2. So we are going to meet again in another class working with different questions for mathematics N5. So subscribe if you are new, and don't forget to share our episodes to your friends and colleagues so that they also can revise with us at Maison African Motives. Till we meet again.